You tell me when you're ready, Brian.
I'm good.
Hello, everyone. Thanks for joining us. I'm Craig. I'm going to be the afternoon moderator, it sounds like. So for those of you that were here earlier today, Tanya didn't just get uglier. So, no, I'm glad to have Trihydro here and have Brian Palmer with us. Brian's got about 14 years of experience within Trihydro on their air compliance team. He's led and managed some LDAR programs for over 30 midstream operating facilities, and including several program and implementations and transition projects. His career passion is helping his peers understand, grow, and improve their knowledge and work product by working closely with them using real life and practical experiences. Brian? Appreciate it. And real quick, we would ask if you can pass around the sign-in sheet. He would love your autograph, and to kind of see who you are, and pass that around as he gets talking here.
Thank you. Also, if you guys got one of these cards, if you have questions or want to see some specifics on these slides, you can scan the QR code and it takes you right to the website. You can actually see all of our presentations there. So, okay, so I'm Brian Palmer with Trihydro. Like I said, I've been in LDAR for about 14 years. I started as a technician, currently team leader for Trihydro. So today we're going to talk about Method 21 versus alternative work practice, a little bit of case study of what that looked like going from Method 21 back to traditional LDAR programs. So we're going to go through what might make method or AWP more appealing in traditional Method 21. Look into what some of the reasons following an AWP might be changing. A specific case study that I had for you guys. So what some of the factors went into their decision to go back to traditional Method 21, and how it went. So what we saw in the field, some of the things that we did right, how we could have done things better, and a few key takeaways. So first, Method 21 is the alternative work practice, 60.18. Really, the big differences between the two, in a nutshell, is traditional Method 21, is a point source inspection, just with TDA defined. It's a quantitative reading, so giving you a part per million. It requires monthly, quarterly, annual inspections at a part per million. Alternative work practice, bi-monthly surveys with an OGI camera. It's generally a broad survey of equipment and not necessarily immediate to the specific component. So two big differences there is KPIs. So I mentioned monthly, quarterly, annual schedule. If you look at a facility about 2,000 valves, that's anywhere from 14 to 18,000 inspections a year based off those different KPIs. Whereas alternative work practice, we might be looking at doing that same number of components in a single day with a camera. So, so in a nutshell, as provided in a response to comment from EPA, AWP's idea and development was centered around modern technology and emission reduction equivalency provided in current work practices. So in a nutshell, it's going to save time and money. That said, so some things to consider if you are considering going to an AWP or already in an AWP, was the proper documentation provided or request provided to the administrator? What's all included in your requests? What some regulatory risks are even having an alternative work practice? If maybe there's some acquisitions coming along, complacency and redundancy, and I think arguably, there is a level of complacency and redundancy in Method 21 monitoring. following EPA's best practice guide of 250 to 350 valves per day per technician, gets pretty redundant. It's very easy to become complacent. Even more so when 98% of those inspections, you're not even be leaking components or leaks. So, I've been doing this for 14 years now, and about the only thing more redundant is coaching my 6-year-old's baseball teams. So, I think that said, I think that what EPA's idea in 2008 with modernizing some of these work practices and procedures with the new technology, proves that it sort of provides just as much risk for complacency. In some cases, maybe more. Sorry. And so, I hate to beat a dead horse this week, but, some of that reason is regulatory reform. So, looking at complacency, and there's Appendix K. So this is, the method 21 or the method to OGI monitoring as method 21 is to LDAR monitoring. So looking at the case study, I'll go into a few details on here, but it is a midstream gas plant. 2 different facilities. One was done alternative work practice. One was done method 21. I think in this whole lesson, I think the biggest takeaway is really just making sure that us as consultants or you guys as operators have a solid understanding of your LDAR program. So having a solid understanding of what those risks are, staying in contact with your operator client, making sure that they're in communication with you, is really important for successful LDAR programs. I think that we all agree that AWP can work and you can find leaks. But like I said, there's, knowing what that regulatory risk is important, because if AWP is not implemented or followed correctly, it could be pretty catastrophic to your LDAR program. So what weighed into their decision to go from AWP to traditional method 21? Acquisitions, so just driving consistency across different programs. Like I said, one facility was method 21, the other was alternative work practice. Concerns of potential non-compliance because of those differences. So asking the whys, the whats, and the hows. But with those regulatory concerns, concerns with the regulatory reform, such as Appendix K, what is alternative work practice going to look like, or what could it look like in the future? And then, of course, just possible enforcement. So I'll start with Appendix K. I mentioned that it is, its proposed method to AWP as method 21 is traditional LDAR. Basically what it's doing is just bringing structure to an already loosely written method and alternative work practice. So it's bringing a little bit of structure to that by dictating who can complete surveys individually, so specifying training requirements, inspection times or survey times, things of that nature. Increased costs as a result of that. So I mentioned that one desirable thing was, time and money. So with more training, more individuals, so on and so forth, through are potentially increasing costs. So maybe it's less of a cost benefit. However, that being said, is Appendix K does remove the current standard and alternative work practice of doing an annual method 21 monitoring event. So I would say that might be the only benefit. So driving consistencies across their programs, this is where they really started asking the why-rs. So why are the monitoring frequencies differently? Why am I finding more leaks at this facility and not this facility? Why is there LDAR tags at this facility and not this facility? So I think pretty important questions. We also went in very early on in this project, some of the regulatory concerns that we had was just work practice concerns. So lack of leaks being identified. So there was a low number of leaks initially identified compared to what we're used to seeing in industry. A little bit of unfamiliarity with repair schedules. That was both on the contractor and the client maintenance. You're running two different programs. One really similar to Quad OA compressor stations. Is that repair schedule the same as it is in a Method 21 program, or even Quad OA subject gas pumps? So were all the Method 21 requirements being followed for that alternative, that annual Method 21 survey? What was inspected and what wasn't? So I mentioned, they had questions of, well, why is this equipment tagged and why is this equipment not tagged? So, having a lack of a component identification was a piece of that. And then which carried down into that annual Method 21 inspection. And then AWP does require that you complete your Method 21 inspection every 12 months. So because of the lack of records, there was no, information as to when that Method 21 survey was complete. So if it was done every 12 months. Okay, so a little bit about what we expected to see. So as you can see in this graph here, on the right, facility, we find the same facility would find about 130 annual Method 21 leaks. So keep in mind that these 130 are only greater than 10,000 parts per million. So typically, I think, most of us can agree that a camera can see leaks greater than 10,000 parts per million. Maybe in the perfect conditions, less, or depending on the environment, maybe less. And at the, what we would expect to see based on bi-monthly OGI schedules at this facility is about 50 annual OGI leaks captured. So most of these primarily big leakers, just identifying the big leaks. So kind of following a little bit of the intent of alternative work practice, this is what we would expect to see, or what we expected to see. Yeah.
Out of curiosity, Brian, on that. 10,000 pounds, 20,000 pounds.
So this facility is about 5,000 valves. So yeah. Yeah, and I mean, even looking at this, you can see that, like I said, 46 of this 130 were greater than 10,000 parts per million. So that roughly equates to about your 50 OGI leaks. So this is what we actually saw. So there was less than 5 annual leaks found in a year during a bi-monthly OGI survey. During the annual Method 21 event, we came in and found, approximately 270 leaks. 105 of these were greater than 10,000 parts per million. So big difference. So you can, when I get into
That's really like it though.
say that again. What's that?
Maintenance was supporting the camera, use of the camera.
And that's a pro camera.
Yeah, so, that's what we expected to see versus what we saw. These are in order, but okay, we'll roll with it. So with those leaks, the record keeping requirements, we identified that possibly there was no documented approval. That was done because of changing hands and things like that. People involved just couldn't answer those. Hey, did I request for approval for alternative work practice? Unknown on the OGI piece of things, if the records were recorded or daily verification surveys were recorded. Unknown if the instrument records were kept. DOR records, what did that process look like? Were they authorized or just components that couldn't be repaired? Just said, here's the DOR card. And other non-method 21 record keeping components still required. So calibration gases, all that good jazz, all that stuff that just adds up. And then I think when you have a annual inspection, that you're kind of compounding that if you have a facility possibly unfamiliar with those requirements, that you get maybe a new crew of folks coming in to do the method 21. What do you look for? So that's a little bit of the concerns we had at this facility. Component identification, so limited equipment ID, no process unit identification records. So I think that there's a gray area, agree in the reg, like what is a component ID involved? How can that be P&IDs? Does it have to be an LDAR tag? I'm not here to interpret gray. I'm just going to say LDAR tags. So it was lacking that. So their other reason is possible enforcement. So with alternative work practice, we all know that EPA can dispute the results that are obtained in your alternative work practice. So if you're submitting those and they come back and they say, prove it, they can ask you to prove it. And, because of the lack of records, that's a concern. Yeah. And when they ask you to prove it, they'll ask you to compare using a quantified method. So, there would be concern if you didn't know what your other program was like, and now you have to come in and prove it with method 21. We saw the graph, right? They're going to be concerned about equivalent means of emissions. So unannounced site visits, they can, I think that this is being talked about a lot this week with, third party, what does that super emitter program look like? I think we expect some of that might change, but it's out there as proposed right now. So that, could initiate unannounced site visits, data requests, and consent decrees. So, which we are in the midstream sector seeing, just one more regulatory presence. So the possibility of consent decrees is getting, higher and higher for the midstream sector as, time goes by. So with this, we identified, or the client identified, hey, we want to make a change from alternative work practice, go back to method 21 LDAR monitoring. So what we did, first, we started just basically from scratch. I don't know if this has to take place at every facility, but what we opted to do with this, because of the limited inventory, was start from scratch. We took their P&IDs, we marked up a LDAR specific set of P&IDs. So, what was included in the LDAR program, what wasn't, different rules, so closed vent system, so that we can be transparent with our clients on applicability on components. We also completed the annual Method 21 event, running concurrently with the tagging. So there was a lot of inefficiencies, call it. A lot of confusion going on back and forth between the two. So some of these inefficiencies, because of the lack of identified components, I kind of laugh at this, is we had our client come out and we had several LDAR techs monitoring, and he walks up to him, he's like, hey, how do you know what to monitor? and the LDAR tech was like, look, man, if it comes apart, if it moves, it's getting an inspection. So, I mean, that's kind of what we were up against, because, for me to get the job done in the time that we had, it basically was, until I have this stuff tagged, they might have a general idea and understanding of the regulatory requirements and process, but kind of start on this line and just keep going. And then when they found a leak, we hung an LDAR tag on it, documented the leak. We gave it a unique ID at that point. So then when we got to that tagging event, I had my LDAR specific PNIDs. I looked at that component and was like, oh, well, that one's not actually part of the LDAR program. They're still gonna fix it, because they're being proactive about their LDAR program now. So they're still gonna fix it but we're not gonna report it as a leak as part of the LDAR program. So we were able to kind of mitigate that a little bit with over-reporting leaks, so to speak. So knowing where we ended, where we began, that was, like I said, starting on one line and progressing through, utilizing the PNIDs. We found a large amount of leaks. I said the annual monitoring event is every 12 months. So, approximately 20,000 inspections in like no time. And we found 270 leaks. That's a pretty significant volume of leaks with, maintenance coming out, doing repairs with us, going back out, so on and so forth. As far as the component tagging went, as part of that annual method 21, we're doing a survey of everything, right? So we're capturing records of connectors, valves, pumps, PRVs, everything. The only connectors that we identified at that point initially were only the leaking connectors. They're required to report their semi-annual leaks, right? So we identified the leaking connectors at that point uniquely, so they were specific, and then all the other leaks go there on and so forth. But we did hang a tag or identified initially pumps, PRVs, closed vent system, and then we did that initial inspection, call it on CES, all of that stuff. The children components or connectors, we came back when it was all said and done and inventoried those non-associated or major component or equipment after tagging and inventory was complete. So really it was kind of a two-phase component inventory project and a one-phase annual monitoring project. We also produced written LDAR plans, provided LDAR program training, and then, with our LDAR programs, it also increased the monthly QAQC. So we're running ad hoc QAQC reports on this data that previously had not really been QAQC. So what went right on that project? We kept a consistent project team. So the same people that started the project, it's the same people that finished that project. Myself, I was heavily involved. I was, out there for long periods of time. But we set that schedule with the client, asked what their needs were, and we met those needs. So we stuck to it. I understand, it's LDAR. Weather doesn't wait for LDAR. Always. Can't say never, but so we set that schedule. We had anticipated upsets or unanticipated upsets, but we had a plan B, to make sure that we could stick to that schedule. We set expectations, both Trihydro and client-driven expectations, and we managed them. We completed that PNID set early. We had frequent progress meetings, so basically constant communication. I think by the end of this project, the control room, the plant manager was so sick of hearing my voice because I'd come in and I was like, hey, good morning, today we're going to be over here and we're going to be doing this. And I'd come in at the end of the day and say, hey, good afternoon. We did this today. Tomorrow we're going to be doing this. And this was every day on site. And I mean, I'm sure I drove them nuts, but it's that constant communication keeps everybody happy and informed. So they were also able to provide us with a consistent maintenance team. So this was important for those leaks because they could find a large number of leaks. So I know a lot of operators may not have that ability to give you that same team, but it also worked with our schedule where we could come out, for the X amount of time, get tagged with that maintenance crew for X amount of time, leave on their shifts off, come back when they're back on, and they were familiar with us, you know, we had good rapport, good communication with them. So a couple things that could have prepared us a little better. So, you know, having an understanding of, or maybe a better understanding of what some of those issues were prior to kicking off the project, and communicating those issues and solutions, you know, so identifying the problem, coming up with a solution, and communicating that and putting that part of our work plan. I think that that could have better prepared us. Having more or better background documentation, you know, looking at some of the reports, was there any other applicability determinations, different procedures and protocols? Time. I mean, you know, time is of essence in a lot of what we do. And oftentimes, all our programs, we don't get a lot of time to do this sort of transition. And time would be great, but I want it yesterday. So time would have been great, but, you know, had the time been available, you know, maybe we would have done just the tagging first, inventoried all those connectors first. I think there would have been a little bit less inefficiencies on some of those monitoring issues, on monitoring stuff that wasn't in the program, you know, vice versa. And then, but having a facility specific documentation protocol. So I think a lot of us in the LDAR industries, providers, have a company documentation protocol in place, what we're going to do, how we're going to inventory it, things of that nature. But, you know, really having a facility specific protocol that outlines, this is what I want you to include in your location description, how we're classifying components, elevation codes, things of that. I think that that would have been great. But now that they're in Method 21, you know, how does Method 21 improve their LDAR program now? So there's increased QA/QC, you know, more program accountability. You're able to run, I mean, you can run LDAR data this way, that way, from each way from one another, you know, but, you know, without just looking at data, you know, there's more accountability in Method 21 data right now. You know, that holds up to data integrity. You know, is it, I don't know that there's any LDAR program that's audit proof, but is it audit ready? Risk management, so you're managing risk in that case. Emission calculation, so Method 21 LDAR monitoring allows you to run quantitative results, lower reported emissions. So I don't know that if it gives you, like, it doesn't give you lower emission rates, but it gives you lower reported emissions over the year. And it's no longer a leak, no leak sort of report. It gives you, you know, a duration for that inspection as well. So some of the key takeaways is knowing where you're at and what the requirements are. So I think that this is both for, you know, myself as a consultant and operators. So knowing where my program is, what my clients' objectives and goals are in their program is important. Making sure that we're working as a team to achieve those goals. Understanding the risks. So, I mean, I said AWP is written pretty loosely. So understanding what that looseness is and, you know, how to reduce that risk within that. You know, I mentioned, I think that if it's implemented correctly, I think AWP can work really well. But if it's not, you know, you could be faced with the graph that I showed you. You know, if there's some misunderstanding in that. And then have regular communication, both as a contractor and an operator. So that doesn't have to mean, you know, your project manager with your LDAR coordinator. That's like your entire team. Maybe there's different meetings for different objectives, but having that constant communication involving everybody, you know, makes your LDAR program great. routinely ask the what's, where's, who's, and why's. So why was this added into the LDAR program? Do I have an MOC for it? Where is the MOC? What was part of that MOC? What can I give you as an LDAR contractor to make sure that compliance is met? And then, does the data make sense? So does it make sense that we're out here with a camera, we're not finding any leaks? You know, I know that there could be leaking stuff. Does that data actually make sense, both with AWP and Method 21? Does your data make sense? All right. Any questions?
They're using the right camera.
What's that?
They're using the right camera. Nice camera.
Say it was a natural gas processing plant where the case study was done.
Yeah, mixture.
Was the outcome the anticipated results versus the actual results? Was that a deciding factor in the site going back to back to 21?
I think that was part of it. You know, it was a lot of the questions on, you know, why is it differently here, you know, than it is here, and then seeing the results and saying, you know, like we're finding leaks, right? We want to find leaks before they get found in an audit, so to speak, or an unannounced visit kind of thing. So, and then, you know, with Method 21, you're getting a point source inspection on those components more frequently. So.
One thing I'll point out, Brian, is you know, they use the had some alternative work practice sites. It is both pieces of it matter. Camera matters and the Method 21. You can't be so camera focused that you ignore the Method 21 piece. Nor can you be so Method 21 focused that you don't acknowledge the camera piece. So both of them did a good job dictating or telling us how they both had to be at the same time. So yeah, they're detecting it with lemons, but the quality of work for both aspects have to be on the same level. That's one thing I saw 5 years ago. It felt like the OGI was the more important version than the Method 21 version. And for practice to work, both of those pieces have to be done correct.
Yeah, so I mean, like Don was saying, it is emissions reduction equivalency provided in the current work practices. So as long as there is that emission reduction equivalency, you know, I think AWP works. And if you have that same, you know, goal or process oriented OGI inspection, you know, AWP is great. So, and also at reducing costs. Okay. Well, again, QR codes on the cards that we passed out. If anybody didn't get one, just catch me at the door and I'll make sure if you want a copy of the presentation, I'll get one to you. Or if you guys have any questions, happy to chat. So.
Thank you, Brian.
Break. 1:40.